Welcome back to the next video lesson in the series. Today we're going to be discussing wave interference. What is a simple definition of wave interference? When two waves cross each other, they either build a bigger wave or sometimes subtract away and build a smaller wave. If they build a bigger wave, that's called constructive interference. If they build a smaller wave, that's called destructive interference. Let's take a look at some examples. Here we have a wave simulation from the physicsclassroom.com. This is a wonderful app and I'd like to explain to you how it works. The first thing I want you to see is that there is a red box with controls. And this red box controls the red wave that you see above. The frequency, the wavelength, the speed, and the amplitude are all given by these values. Half a hertz, 1 meter, half a meter per second, and 0.2 meters of amplitude. That is the data that's happening in this red wave right here. Now I'd like to turn your attention to the blue wave right below it. It looks identical. And here we have a blue sine wave. It has the same frequency as the red, 0.5 hertz. It has the same wavelength as the red, 1 meter. It has the opposite velocity, so they're going to go towards each other. They're going to meet. And then, of course, it has the same amplitude. So I've chosen to have an identical wave moving towards the red one. So blue and red are identical waves. Now, to prove that blue and red are identical waves, even though you can look at them and visually inspect them and see that they are, in fact, identical, I will merge the two waves. And there you can see 1 plus 2. Both of these waves. Now when they add together, you get this 1 plus 2. Now I'm going to set both waves in motion. You can see that the red wave is traveling to the right and the blue wave is traveling to the left. And what is this below? This oscillation up and down? Well, this is actually the sum of both waves adding together. Let's add blue and red on the same line. So as we have blue and red meeting each other, crest meets crest, crest meets trough, and anywhere in between, their sum changes. I'm going to slow down the video so you can see it. Now here we have the merged red and blue waves on the top row, and we have their sum in the bottom row. I'm going to slowly set the waves into motion, and we're going to watch the offset of the wave and what happens to their result down below. Here we go. Notice as red and blue begin to offset, the total of their peak begins to decrease. Let's keep going. And there we have the red and blue are completely offset from each other. This is what we would call a 180-degree phase shift. When the waves were on top of each other, they were in phase and you got maximum constructive interference. But when the waves moved 180 degrees out of phase, you now have maximum destructive interference, and you can see that their result is a flat line. Let's run the simulation a little longer. And there we have the waves adding back up together to give you a maximum constructive interference. So these waves are 0 degrees and 360 degrees in phase. Now I will run the simulation one more time, and you will see the waves slowly move out of phase. And as they move out of phase, you will see this purple wave here, which is the sum of the red plus blue, eventually flatline to 0. Okay, let's take a look. There it goes. It's getting flatter. And there it is. The red has a maximum, but the blue has a minimum. Then the blue has a maximum, and the red has a minimum, and so on and so on. The red maximum here cancels with the blue minimum there. And the blue maximum here cancels with the red minimum there. Let's run the simulation one more time and go from maximum or total destructive interference to maximum or total constructive interference. There is no wave visible in the sum of both waves, but now the two peaks are converging. And here we have an amplitude that is double. These two amplitudes add up. Here's 1, 2 boxes. Here's 1, 2, 3, 4 boxes. So the amplitude is the sum of both of these waves. Okay, let's take a look at another kind of interference. In this next example, I have changed the amplitude of the blue wave to be taller than the amplitude of the red wave. So the red wave was originally 0.2 and the blue wave was originally 0.2. But then I've almost doubled the amplitude of the blue wave. Let's take a look on the effect of the combination or the superposition of both waves. I will merge the red and the blue wave. And when you see that I've merged them, you can see that the sum of the two waves, red plus blue, gives you something a little higher. So from this baseline, 1, 2, 3, 4, 5, 6 boxes, which is the sum of these two waves, 4 plus 2. Now I'm going to run the simulation and let's watch what happens. Will these waves totally flatten out? Let's see. Running the simulation, we can see the blue wave is always larger than the red wave. And even in the places where the red wave is subtracting from the blue wave, such as here, you still never bring the sum total of the amplitudes to 0. In order to have a 0 amplitude, you have to have the exact same amplitude of both waves in order to get maximum destructive interference. So this is what we would call partial destructive interference. Let's run the simulation a little longer. So the maximum growth of the wave goes up to the sum of the two amplitudes, 4 plus 2. And the minimum goes to the difference of the two amplitudes, 1, 2. 4 plus 2 and 4 minus 2. So the minimum amplitude that this can have is a positive 2. What's important to understand is that when the blue wave is at its maximum and the red wave is at its minimum, a positive 4 minus 2 gives you an overall of 2, a remainder of positive 2, so the wave will have an amplitude of 2. Let's take a look at when the blue wave is maximal. The blue wave has a negative 4 amplitude here, and the red wave has a positive 2. Negative 4 plus 2, negative 2 amplitude, and that would account for why this wave has a negative 2 amplitude when you add them together. But notice, these waves never add to 0. Okay, that concludes our lesson on wave interference. Okay, that concludes our lesson on wave interference. Thank you for watching. I hope you enjoyed this, and we'll see you in the next video.